Okay, we're going to find the domain and range, and this time we're going to write our answers in notation form, which basically means with parentheses and brackets. And remember this, a function is only limited for a function when you have a what? Square root, or a rational function, meaning a variable in the denominator. This one is a rational, is a square root function, and they would say the reason is it possible, can you do the square root of -1? No, that does not make it a real number, it makes it an imaginary number. So therefore, I know this, x minus 4 is good for any number such that it is greater than what? 0. Well, basically I add 4 to each side, plus 4 plus 4. As long as x is greater than or equal to 4, that is my domain. Well, how would I write that in bracket form? Well, think about it. What's the smallest it can be? Is 4. Can it equal 4? Yes, so that would be a bracket. And then I can square root any number up to infinity greater, so it's going to go to infinity, and infinities are never brackets, they are always parentheses. Now that is the domain. Well, think about this, the range would be the following. The smallest value it's going to make is when it's 4. If you were to plug it in, what is the square root of 4 minus 4? Well, 4 minus 4 is 0. The square root of 0 is 0. So I know it's my smallest value. And as I plug these numbers in, think about it, it's going to go what? To infinity. And to be honest, you get bigger and bigger, the number's just going to get bigger. So here, I can have 0 as an answer. So my range is from 0 to infinity. Now this one right here is an absolute value. Now I will say this here. X is not particularly limited here because x can be a negative or a positive. What's going to happen is you're going to end up getting positive answers, which is going to affect the range. But the x is not limited any, so it is in a sense all real numbers, which for notation form will be negative infinity to infinity. All right? And now then what I want to do is this here. How would I find the range? Well, think about it. You're going to make this what? Whatever you have a negative answer, you're going to make it positive. The only question is, can you have 0 for an answer? And you sure can. Because if x is 2 minus 2, what do you have? 0. And that is an answer. But any other number, whatever you have, is going to be positive only. So therefore, I know my range will be from 0 to infinity. All right? Now that we have those up there, I want to go ahead and show you something else. Another way to particularly do this might be a little bit more helpful. I'll leave that right there. Here were the answers. I hope you have them. I'm going to erase that in a second. And I'm going to show you another way you can do these with the calculator. Also kind of help out and to check your answers. So if you go to your calculator right here, turn it on. All right. And I'm going to go to my y equals button. And what I'm going to do is this. I'm going to go second square root, because this is a square root, and do x minus 4. And then I can hit graph. And you can see right there, there are no x's over here. And if I went to my second table, you can see errors on all the numbers until I get to 4. That would also help you know that the domain is only from 4 on, and that the range is from 0 up, which is what our answer was. All right, so let's clear that one. Back to our y equals. And this time I can go here to do absolute value. I'm going to go y equals, and then I'm going to hit math, arrow over to numbers, and option 1 there, or just enter, it's already on 1, is absolute value. And I'm just going to go x minus 2, and I can hit graph, and you can see the graph looks like that. Okay? And what I want to do is this here, go second table, and as you notice, I'm going to arrow up, you see no negative y values, and you can see that the x's that could go forever and ever, they're going to go each direction that way. So just kind of wanted to show you that as another way that you could do that particular one right there. So now then, let's kind of go look at our next two problems that are very, very similar. All right, we have those right there. First off, so I'm on the calculator part. I'm going to go ahead and put this in here. Let's clear that out. That would be 2x squared minus 3, and I can graph it. And I can tell looking at it, I'm going to have a domain that's going to go forever and ever, but I am limited with my y's. Looks like to me this at 0, -3, looks like the smallest value right there. That's going to be helpful, and I can tell it's going to go forever in other directions. So I want you to remember that. I'm going to go work it out in a second. And I'll tell you what, let's do. Let's just put in y2, this second one right here. We'll just put x plus 1 and graph it. You can see it looks like it's going to go forever. And if you were to do second table and look at table 2, you can kind of see that the numbers do. That one's not going to be limited at all. So let's go back and now let's show it more algebraically and write down the answers so we can see it a little better. And once I said earlier, if I was to do this particular problem right here, notice it's not a square root, it's not rational, so I know it is all real numbers, which the answer will be negative infinity to infinity. We saw that on the graph. And when we graphed it, we saw it went down to -3 and then went up at 0, -3. And think about it, squares aren't going to allow you to have anything negative at all, but this -3 took that 0 value and moved it down 3. So therefore I know that this will go from -3 to infinity for the range. And this one right here, x plus 1, it's not limited at all. And it's a graph, it's linear, it goes on and on forever, left and right, up and down. So that all the answers for number 21 will be this. It's all real numbers, flat out, all the way around for that. So that's finding the domain and the range for different functions.